Hi everyone, welcome back. So the challenge for today is can we place the given flowers? So you will be given a long flower bed in which some of the plots are already planted and some are empty. So but flowers cannot be planted in adjacent plots. So there should be a gap of at least one flower plot. Given an integer array flower bed containing zeros and ones where 0 means there is an empty flower plot and 1 means it is already occupied, and an integer n, we need to check if the given n flowers can be planted in the given flower bed or not. And we need to take while planting the flowers, we need to take care that we don't violate the adjacency rule that we have discussed here. So let's look at the examples. So we have a flower bed of 1 0 0 0 1 and we need to check whether we will be able to plant one flower plant. So because we have three empty places here, so we can plant the given flower in the middle and there will be an empty flower plot on the adjacent side, so we can return true. So in the second example we have the same flower bed but n equal to 2. So if you see, we have only three empty places, and to make sure that we follow the adjacency rule, we cannot plant two flowers, because if you plant one flower bed here, the other two cannot be used. So here output will be false. So when it comes to constraints, the flower bed length can go from 1 till 10 power 2 star 10 power 4, and flower bed of I, the value will be either 0 or 1. So 0 means empty, that means we can use it for planting. 1 means it is already occupied. So there are no two adjacent flowers in flower bed. So the initial array that we will be given will be, it is already satisfying the rule of adjacent non-empty flower bed. So the length of flower bed will be the number of flowers that we need to plant will be less than the flower bed length. So what should be our approach? So I think we don't have to think too much. We can just go ahead with a normal approach, like we can do brute force approach. Like we can start from the 0th position. Let's say we have here, so we can start from 0th position and keep checking. So whenever we encounter an empty index, an empty place, we just need to check its adjacent sides, left and right, and see if they are empty or not. If they are empty, we can go ahead and plant the flower in the current position. If one of them is not empty, we cannot take the current position for planting. So that way we proceed till the end of the array. So let's look more closely with one example. So let's say we have a flower bed like this. So let's take a typical example where we have all empty flower pots. So we will start with the first position. So it doesn't, because it is the first position, it doesn't have a left position. So we need to check its right position. So we need to make sure that it is also empty, so that we can plant a flower in the current position. So the right one is empty, so we can go ahead and plant flower position, and we need to mark it as 1, so that next time we know that it is already planted. Then we go to second position. Then, as you know, it has both the left and right adjacent positions, so we need to check. And the left, as you see, the left one is already occupied, so we cannot plant here. So we need to move to next position. Then again check the adjacent positions, so both are empty, so we can go ahead and plant here. Then move to next position, and its left one is already occupied, so we cannot do anything here. Then go to next position, and it has two empty adjacent positions, so we can plant. Then the next one again has left one already filled. Then finally we have an empty position, and its left one is already empty, but it doesn't have a right one, so we can still go ahead and plant. So the answer will be 4 here. So we can plant a maximum of 4 plants here. So if the given n is less than or equal to 4, we can return true. But if the given n is greater than 4, our answer will be false. So let's go and check the source code. First let's check Java solution. So n equal to flower bed of length, and we go from 0th position to n minus 1 position. So 0 to n, 0 to n minus 1. And the first thing that we need to check is if flower bed of I equal to 0, that means the current position is empty. Then we can go ahead and check if it has an empty adjacent positions. So here we are taking care of the first index and the last index. So for the first index and last index, we don't have to check left hand. For the last index, we don't have to check the right position. So if I equal to 0, that means if it is first position, then we can if the current position is so if I equal to 0, that means it is the first position, so we just have to check the its right position. So flower bed of I plus 1 should be empty. And if it is I equal to n minus 1, so for the last position we just have to check flower bed of I minus 1 equal to 0. So the current position should be 0 and its previous position and its next position should be 0. Then once we note down the current position, then we need to mark it 1, so that for next time we just for the next position, when we check the previous position, we make sure that it is already filled. And finally we calculate the total count, the number of flowers that can be planted, and if it is greater than n, we just return true. So let's execute and check. So it works fine. Let's submit. Yeah, the solution has been accepted. So let's check C++ solution. So it will be pretty identical except a few syntax changes. So again we check from position 0 to n and the same conditions. So if it is 0, if I equal to 0, then we don't have to check I minus 1 position. If I equal to n minus 1, we don't have to check the I plus 1 position. And we count all the valid positions and finally check if the count is greater than or equal to n. If it is so, then we return true, else we return false. So let's submit and see the runtime execution. Yeah. So all the test cases have been passed and a runtime of 32 milliseconds. So as we accepted, this is an O of n solution because we traverse the given array, we process the given array once. So it's O of n solution, and thus, when it comes to space, we don't use any additional space, so it is constant space. That's it for today. Thanks for watching. Thank you.